Hello everyone, my name is Malvika Gupta and today we are going to discuss a sorting algorithm called selection sort. In this video, I am going to cover these topics regarding selection sort. First of all, introduction, example through which you will be able to understand how it works, pseudocode which will help you write the code in C language or any other language, time complexity, the running time for this particular algorithm, and then at last I will be telling you how to write a code in C language. So let's first start with the introduction. As we know, first of all, we should understand what do you mean by sort. Sort means arrangement of elements, either in ascending or descending. Always remember, if you are not being given that yes, in which order you have to arrange the list of elements, and every time by default the arrangement of elements should be in ascending order. So always remember this point. Now in this we are going to discuss about selection sort. What do we mean by selection? Why the name has been given to this particular sorting technique as selection? In this sorting technique, what we are going to do, we are going to select each and every element present in the list of array as the minimum element and then performing the comparison to get a perfect ascending or descending order, whichever has been demanded. Suppose this is just I am telling you how to do this one. Suppose this is my array given to me. So what I am going to do every time, because every time you have to traverse, if you are going to arrange this thing, then it means that you have to traverse each and every element. Only that you will be able to identify that which element should come at the 0th index and which element should come at the last. It means that I assuming that this is my first minimum element. It means that 0th index is my minimum index. This I have assumed, I have selected. And the rest of the array, what I'm going to do in this, I'm going to search in this particular section of array that whether is there any element present which is less than this element which I have assumed as the minimum. So in the first step, I will get this. Same thing I will repeat for the second step. What I will do again, after moving from here, after performing the concept, after getting the minimum element at this particular position, what I am going to do, I will be selecting first as my or assuming first as my minimum index. So it shows that this 3 will become the minimum element. Again, I will be searching the minimum element, then this 3 value from 2 and 3 index value, right? So if you get any other value which is less than 3, then again you will be changing the positions of that and moving ahead. When I change the position, again I will be selecting this 2 as my minimum. Then again, this is the part which I am going to do. In this, if this is the minimum element, then this element, then I am going to swap the positions of these two elements. At last, I'll move to this one. And now you can see that there is no element left in this. So I'm not able to compare it with this one, right? As we know that for comparison, at least 2 elements are required. So this is how selection sort works. Selection sort works like that we have to select a minimum element from the given array, and that minimum element we have to assume each and every element has to be selected as the minimum, and then we will perform the swapping as per the requirement, right? So this I will be explaining you using this particular example. Now see, you will be able to understand this more according to this example. Suppose this is my array. So I'm starting doing this from here. Okay. So first of all, I will be beginning from 0th index. As you know, array will be starting with 0. So I'm taking it as 0. I'm not considering it 1 or 2. So minimum. This is my minimum. This is my first minimum I have selected. It means my minimum index is 0, but my A of min is 5. Okay. The value at minimum index is 5. So now what I'm going to do, I have to search from this section of array that is there any element which is less than 5. It means that you will be running You will be traversing from 1 to 4 to search if there any element present which is less than 5. So how I am going to do? I will be searching it like this, that if my A of min is greater than A of j. So A of j you will keep on changing. First of all, it will become A of 1. So my minimum is 0 and my A min was 5, which I can get from here, and I have also written over it over here. Now A of 1 is what? It is 3. So if you see 5 is greater than 3, condition is true. If it is true, it means that your minimum will change now. Minimum index will change to 1 because I am storing only minimum index. So that is why I am writing here only 1. Again, if I go, I will check A of min because still elements are left. A of 2 because I have to go till 4 for this one. A of min is 1. So A of min, my new minimum is 3. Minimum element is 3. I will be checking it with 4 because A of 2 is 4. 3 is greater than 4. Condition is false. So there will be no change with the minimum. Still my minimum index is 1. Again, I will be checking for A min is greater than A of 3. A min is what? A1. A1 is what? 3. Still the same. A3 is what? 2. Okay. So now 3 is greater than 2, condition is true. If it is true, then you have to change the minimum, and now my minimum will become 3. Earlier it was 1, but now it has been changed to 3. Now A of min is greater than A of 4 because the last value I have to take. My minimum index is 3. So what is the value at A of 3? It is 2 is greater than 1. Condition is again true. So minimum will become 4. And now if you could see that there is no other element left, so we'll stop traversing at this point only. Now you can find out that minimum, my minimum is equal to 4. So if it is 4 and we started with 0, now you see we have a difference in the index. We have another minimum value which is less than 5. So what I am going to do, I am just going to perform a swapping operation, right? So what I am going to do, here I am going to put 1, then here 3, 4, 2 and 5. These two positions I have swapped, 0th and 4th index. I hope this is clear. Till now, it is clear to you. Now, this is my second step. Second step, again, this is going to be my minimum, the next minimum. So minimum is at 1, first index. So it means my A of min will be how much? It will be 3. So I will be selecting, or I will be traversing this part of the array to check whether is there any element present which is less than 3 or not. So it means I will be checking from 2 to 4. So here A of min, the condition will remain same, is greater than A of 2. I'm not writing A of j because now you have understood. A of min is what? It is 3 is greater than. A of 2 is 4. So if you see condition is false, so there is no need to change the minimum. Minimum index will remain the same, which is 1. Again, A of min is greater than A of 3. A of min is 3, but A of 3 is 2. Now, if you see 3 is greater than 2, condition is 2. It means my minimum index will change to 3 value. Again, if I'll go from here, A of min is greater than A of 4 because the loop will run up to 4th, last index. A of min is A of 3 is 2 is greater than 5. Condition is false, so there is no need to change the minimum. Minimum will remain at the 3rd index. Now you can see that we have started with minimum or equals to 1, but now I have find out that my minimum value in this array is at the 3rd index. So what will happen? I just need to swap these two values. So how my index array will look like? It looks like this. And 5. 0, 1, 2 and 3, 4. Now I will select this as my minimum. This is my new minimum. So my minimum index will become 2 in the next step. And A of min equals to 4. Again, I will be checking in this part of the array. Only for this part of the array. So it will be 3 to 4. So A of min, again the condition is A of 3. A of min is what? A of min is 4 is greater than A of 3, which is what? A of 3 is 3. 4 is greater than 3, condition is true. It means my minimum will change to 3. Okay. Now again, if I apply, because one more value is left, I have to traverse that part also, A of 4. So minimum is A of 3, which is 3. 3 is greater than 5, condition is false. If it is false, so my minimum will remain the same, which was earlier, which was 3. So as you can see that we have started with min equals to 2, but now we can see that we have the minimum index changed to 3. So we can swap these two positions. So it will be like 1, 2, 3, 4, and 5. Till here you can find out that yes, my array has been sorted, but still maybe possible here it would have been a condition that here it would be 5 and here it would be 4. So until unless I am not going to traverse the entire array, we are not going to stop this loop. So now my minimum will become 3. It means my minimum index equals to 3. So my A of min, which I have assumed, is 4. So J will only go for 4, fourth index. So what will happen? A of min is greater than A of 4, and A of min is what? A of min is, because it was 3, so it will become 4. 4 is greater than 5. Condition is false. So my minimum will remain at third position. Now you can see that, and I cannot traverse more because I have only one element left in this. So my minimum is 3, and after traversing also I got the minimum as 3. So my array, there will be no change. 1, 2, 3, 4, and 5. So I got the sorted array. But now the question arises, because still we have one element. Now you see, you can select this as also minimum. But what will happen? There's no point to take this as my minimum or select this as my minimum, because there is no any other element left in this array. And for comparison, at least we need 2 elements. So there's no point to take or select or to make this loop work for one more time. Okay, so I'll be stopping this loop over here. It means that whenever you are going to traverse an array for the selection sort, so you'll be starting with 0 and you'll be ending at n minus 1. I'm not going to select the last index for this matter. I hope you have understood the example of selection sort. Now next, I'm going to write the pseudocode for this, because whatever we have written, we should understand how to implement it using code. So pseudocode says, suppose I have, this is my selection sort, I am writing the name, selection sort, array I am going to take, and the size of the array, 1. I'm starting it from here, begin. I am inputting an array A of n. Third point, because I have to traverse, so for traversing, I will be starting with 0 to n minus 1, as I have told you, do. Now, in this example also, every time we started with this index, every index we are approaching, we are selecting it as the minimum index. So I'm writing set minimum equals to I. So whenever we change the value of I, it will get updated with the minimum value. Now, because now you can see I have to run a loop which will go like this, because I have to traverse this part of the array, and it is like 1 plus 1. With the index plus 1. Here also, if I selected minimum as 1, then it was starting from 2. If I selected it as 2, it was starting with 3. So like this, I have to go. So it will be I plus 1 up to n, right? Then in this, I am comparing if A of minimum is greater than A of j. Then I was selecting my minimum as I keep on updating this minimum index. If I have this condition as true, it means I am frequently finding a minimum value, then the selected value. Once this loop gets over, what I am going to do, if my minimum, as you can see from here, I did what, when this was my minimum which I got after traversing the entire array, and this was the minimum which I selected. Then at last what I did, I just performed the swapping between these two positions. So the same thing I'm going to do, I'm going to write over here that if my I, because my I has never changed, only the minimum was changing, is not equal to min, then what I'm going to do, I am going to perform swapping between A of I, comma A of min. Okay. And then at last, fourth, after ending this loop for I also, I am going to print the sorted array, which is A of n. And in the fifth step, I'm going to write n. So this is how my pseudocode for selection sort works. From this pseudocode only, I can identify the time complexity. If you see, you are understood till now that this is my recurrence relation for time complexity. I started with the n elements, but when I started moving, Every time I'm moving like this, n minus 1, n minus 2, n minus 3, and it goes on until I got the last value. As you can see from here, it is started with n elements, then it moves to n minus 1, then n minus 2, then n, then 1. Only one element at last it was left. So what is the time complexity? This is n minus 1 plus n minus 2 plus n minus 3. This is the summation, and we know the formula for this one is this one, n square minus n by 2. So the time complexity will be order of n square. It means these many comparisons are required. This is actually calculating the number of comparison we are required to do at every step. So this is the time complexity for selection. So now I am going to perform this, or going to execute this code for you in C language. So this is, I'm writing this C language code. Okay. So now C hash include stdio.h void main. Anything you can write. If you want, you can select for, go for int main also. That's up to you. Whichever thing you want. And because I need array, so int a10. N size I'm demanding from user. I and j will be my loop variable, and temp will be a third variable which I'm going to use for the swapping, right? So right, first of all, I'm demanding printf enter, sorry, enter the number of elements. This I'm going to ask from users. Out of 10, they can the user can select how many elements should be entered. So this is like ampersand n. Okay, and then enter the array elements. So printf enter the array elements. Okay, so for this loop has to be run. There's an n. I hope you all know this one, that how to, because this is a single statement, so I am avoiding using that curly braces. Fine. So this is the part which I have included till now. Array has been entered. Now what I'm going to do, I'm just going to perform the sorting, right? So started from here, I equals to 0, I is less than n minus 1. Now you have understood the concept why n minus 1 has been included. Fine. Okay. Now in this set minimum, because minimum I have to set, so I have not declared this minimum, so I am declaring it over here. You can also declare it here as per your choice, min. Now in this for j, and j will be starting with I plus 1, as we have already discussed in j plus plus. So what I am going to do in this, I am going to make the comparison that suppose a of min is greater than a of j. This was my comparison. So I will keep on changing my j. At the end of this loop, we will be getting the minimum value from the index value at the index 0, right? At the at every index, right? So now, if this condition, if suppose now I have to check for that if this minimum which I have got from this part is not same according to what I have chosen at the starting. So then we have to perform swapping. So I am going to write it like this. If I is not equal to min, which I have got at the end, so I'm going to perform swapping. So how I am going to write it? A of I. This I hope you know that how to write it. This is the swapping, the concept of swapping using third variable. You can also write, if you don't want, you don't want to select any third variable, then you can use swapping using one variable only, I mean two variables without using third variable. So this is how I got it. This is my loop ends, and now I wanted to print the sorted array. The sorted array slash n I'm using semicolon. For I equals to 0, I is less than n, I plus plus, and here I'm going to write printf %d. So here is space I'm going to do, and there we go with a of I. So this is the code I have written. So now let's check for this code whether it is running exactly correctly or not. So let's see. Okay, so now it is demanding enter the number of elements. So I'm writing 5. So suppose I have taken 5 3, 4, 2, and 1. So you can see that we have got the sorted array. So this is how we have implemented this particular portion, right? So this is the end of this video. I hope you have understood this one. So thank you.